There are multiple ways to flash the firmware onto your device. You can solder wires onto your device, and you can connect these wires to the breakout board itself. Or you can flash the firmware directly on to the IC before you solder it onto your board. In order to connect your device to the breakout board, you're going to use these colored wires that are connected to the breakout board. So be sure to connect ground, VBAT or VCC, your SWD clock line, and your SWD data line. These are the lines that are needed in order to program your device on the board itself. In order to program or flash your firmware onto the IC itself before you solder it onto your board, you can use a vacuum pickup device, and you're going to place it on the IC itself, and now you can remove it and drop it in to the socket. Here's an in-depth and detailed demonstration on how to use the chip socket functionality of this board. You're going to use 2 fingers and press down on either side of the chip socket. Make sure it fully compresses. Then you're going to use the vacuum pen to place the IC in the middle of the chip socket. Make sure you align the pin 1 marker to the top left hand corner of the chip socket. Once it's properly seated inside the chip socket, you're going to slowly decompress your fingers, and the chip itself will be aligned relative to the chip socket. In order to connect the chip socket programming fixture to your laptop, you're going to connect both USB cords to your computer. One USB cord is for the programmer. The other USB cord is for the J-Link EDU programmer. Once you have the chip socket programming fixture connected to your computer, you're going to navigate to the nRF Connect application. You're going to double click it to open up the application. Once it's open, you're going to navigate to the programmer sub application, and you're going to open that up. Now that you're in the nRF Connect programmer application, you're going to select the device. You're going to scroll down to something with the serial number titled 0002610111197. This is the J-Link EDU programmer. You're going to click on this device. If this message pops up, it's a term of use for an educational version of the programmer, and you're going to click on Accept. You're going to click on that. Now you're connected to the IC device, which states that the device is connected. Now you're going to read the memory to see what is on the IC. As you can tell in the log, there's a 1 non-empty memory block identified, meaning that this is a fresh IC and nothing's been programmed onto it yet. So now you're going to add a hex file. You're going to go to your top right corner and click Add Hex File, and you're going to browse, and you're going to select where the hex file is located that you want flashed onto the IC. The hex file I'm selecting is located on the USB drive, so I'm going to select my hex file and press Open. On the right hand side, you can see how the different memory blocks correspond to different parts of the application, such as the bootloader, the application, and the soft device. Now that I have my hex file loaded, I'm going to write this program onto the IC. I'm going to press Write. And now you press read to verify that the IC has been flashed with the correct firmware. As you can see on the left, the firmware has been written to your IC. Now you can close down the device and you can remove the IC from the chip socket or disconnect your device from the debugging cables. Let's say you connect a device and you want to see what's on it and if it's already been flashed. So you're going to go to read on the right hand side, click on read, it's going to read the IC. It seems like this IC has already been flashed with firmware. Now we're going to erase what's currently on there. Alright, now it has erased the firmware that's currently on the IC, and now we're going to verify that it properly erased everything. So we're going to press read. Alright, so it's read the IC and stated that there is a one non-empty memory block, meaning the firmware has been erased properly. You might run into an error when you select a device and select on the J-Link debugger. You'll see an error that says, could not fetch memory size, could not open device, low level error. If this error occurs, it's probably due to a poor connection between the IC and the chip socket, or a bad connection between the device and the debugging cables. In order to solve this problem, please close out the device, then either reseat the IC in the chip socket, or reconnect your device to the debugging cables. Once you reseat the IC in the chip socket, go to Select Device and reselect the J-Link debugger. And you'll see now that it could properly connect to the device.